Let's see. I think it's going. We will see what happens. Well, good afternoon, everybody. Thank you so much for joining us today for something that we're calling, for lack of a better term, the virtual Minnesota Best Spot Regional Meetup. I'm Yoji Shimizu, and I'm going to be your host this afternoon. And I just have a few words to say before we kind of get into some really great presentations from people that are here with us this afternoon. You know, the first 2020 First Robotics competition season has been suspended, and the first championships have been canceled due to the COVID-19 pandemic. And, you know, as a worldwide community, we're all doing our part to basically successfully meet this really unprecedented situation that we're all in. You know, lots of sacrifices need to be made so that lives can be saved. And that includes, unfortunately, the loss of our competition season. And I know that this is terribly disappointing for all of us, but particularly I feel for all of our high school seniors where this was their last season to compete in firsts. And I have felt this loss and sadness particularly strongly this weekend. Many of us should have been competing, celebrating at the North Star Regional, or the 10,000 Lakes Regional in Minneapolis, or at the Iowa Regional this weekend. And so it's been with me pretty much the entire week, but yesterday morning at 8:30, I was sitting at home and I was thinking about the fact that opening ceremonies should have been starting right around that time. And, you know, so rather than kind of dwell on the sense of disappointment and sadness, we really decided to kind of, just at the very last minute, just try and bring people together virtually and celebrate in a different kind of way, and just to make sure that that we understand that in addition to the disappointment, we have lots of determination and resilience. First Robotics is going to continue. We know it will. It has to continue, and that we're going to use our skills and our gracious professionalism to get through this together and come out stronger than ever. We had really no idea if anybody wanted to join us and do this, so I'm really kind of just delighted that all of you are here. Just to see your faces on the screen just lights me up and makes me very, very happy today. So, so we're here to kind of talk about robots and maybe your outreach, maybe share some of your stories. We've got a little Minnesota FRC trivia contest that we'll do throughout the time that we have us. We're going to give away some swag, and at the end, I think hopefully we'll be able to have some time to kind of answer any questions that you might have about the future and where we're going to go from here. So before we get started, I want to give you a couple of quick announcements about the season, and it concerns a couple of awards. And if you haven't heard about them yet, I just want to make sure that you're aware of them. So first is the Dean's List Award. So all Dean's List semifinalists are actually being interviewed by event judges virtually. And 2 semifinalists for each of the suspended or canceled events will be announced and awarded. So I believe that any of you that are our semifinalists have been interviewed already, and so, or will be interviewed soon. And congratulations to everyone that's been nominated. I'm sure the interviews went great and you kind of just knocked it out of the park. I'm confident of that for sure. The second thing is about the Woody Flowers Finalist Award. That also is going to be selected and announced for all of the events. So again, it'll be based on the essays, of course, that were submitted by teams. So again, a big thanks to the mentors. We want to make sure that we recognize all the amazing mentors and coaches. And then the last announcement is about the Chairman's Award. So it was announced by FIRST yesterday that the Chairman's Award is going to be selected and presented for all regional and district events that have been be selected only on the basis of the submitted essays. So no interviews or other kinds of on-site event assessment by judges. So again, that announcement will be coming out soon about who's been selected. And again, good luck to all the teams that have submitted a Chairman's Award essay. All right. So before we get started, let's all kind of get familiar with Zoom. I think one is if you can, and I hope the bandwidth will allow us to do this, turn your video on and your camera on so that we can all see each other. I think that's a really important component of doing this, I think, in this virtual format. And so let's do this now. Everybody wave, like everybody wave. All right, good to see you. All right. Second, please mute your mic if you're not speaking. You should also be able to get a list of everybody who's participating. I think there should be a button at the bottom for participants so you can see who's online. And then there's also a chat function. So obviously you're welcome to speak up, unmute your mic and speak up, but there's also a chat function. In the chat, you can actually send something to everybody, or you can also send a private chat to whoever's online. So since we can't do kind of quick introductions, let's do that now. Everybody kind of get on the chat and kind of tell us what team you're with. So you can test this out and we can get ready to go. Awesome, look at everybody. Okay. All right, good. So continue to use that chat function during all of our presentations. There's also a place called the reactions button. And that's where you can actually, I think on your image, you can like clap that shows up on your screen, or raise your hand if you want to ask a question, those kinds of things. We can do it that way as well. Someone will be monitoring the chat. So during presentations, if you have a question that comes up and you are feeling a little uncomfortable about just interrupting, just put it in the chat and we'll ask people the questions afterwards. All right. Okay. Anything else? Now we should be doing alliance selection, but we're not. So anyway, we're gonna move forward. And we got a bunch of great presentations. Thank you everybody who's volunteering to say something and to kind of keep us connected today. And so we're gonna actually start with Hannah Reisdorf, who's from Team 4360, and she's gonna talk about how teams can give back during this time that we're in now. Hannah, take it away.
Hey guys, and gals. I think we're probably in the minority. Our team got to compete this year at our regional, and we wrapped up. We packed up our stuff, and we're kind of getting ready for next year. But can you all hear me okay? Okay. Just kind of packing up our year and kind of getting ready for next year. And so we got to compete, and now it's just kind of like that time where you kind of miss your team, and all these other events were getting canceled. So we definitely feel for you. We're not currently meeting, obviously we can't, but just thinking of ways that we could give back. There's a lot of call for, you know, people who have 3D printers to be doing stuff, or access to laser engravers. And so there's been a lot of like medical masks being created, which is super awesome. But another way that maybe folks to give back, and I think I just noticed this myself because I'm somebody who's immunocompromised right now with underlying conditions. So most of our teams have button makers, and so maybe you can connect with your local hospitals or clinics. And I just made a bunch of these. They just say immunocompromised and dropped them off at our local cancer center for anybody who wanted those to just to be able to wear when they go out like grocery shopping, and the nurses were really excited to hand those out to the different people there who might need them. But you know, again, I think we're kind of in a different spot because our season was over already before everything got canceled. But that's one way I think we could all give back, is just connect with those local places and see if they're interested in that. You know, since masks are hard to come by right now, or they're getting hard to come by, but that's something that we all kind of have the technology for, or many of us have the technology for, and we can give back maybe in that way right now, because they don't know, you know, what kind of masks they can accept at certain clinics or hospitals, what's okay, what's not okay. The 3D printed masks are still being tested, and they're not sure about cleaning those, and so that's maybe not the best way right now. It's kind of a plan C that they'll accept them in some places, but I know in our area, up in the Fargo-Moorhead area, they're not asking for those right now because they still have access to the masks that are approved for them to use. So that's another way that we just could give back, and something that we did. So that's all I wanted to share. I feel very sorry for the teams that didn't get to compete, especially the seniors, because that's not our reality. We had to kind of cut our season short. But I feel for all of you that didn't get to go and compete. It was exciting and crazy as always, but you know, we're still looking forward and what we can do next. And if you're a senior who didn't get to compete, you know, come back and mentor for sure. Work with your teams and get a chance to go out there and do it again. You know, even if you can't run the robot, you can still go out there with the team and be a part of your team after this year ends. So don't lose sight of that. Always come back and help out. And that's all I have for everybody, unless anybody has questions for me or anything.
Thank you, Hannah. Any questions or other things that teams are doing right now? Hannah, how many of those buttons did you make?
I only made about 20 of them. We have 2 hospitals and a cancer center in our area, so I just wanted to see if they would take them first. But we could definitely make more, and I think I printed out like 2-3 sheets total, 20 of them, and just brought those to see. You know, so it didn't take me very long, 20 minutes maybe, just to get all the artwork figured out. And I just kept it super simple, just something that would stand out bold-ish. You know, picking a good font and something that they could wear that would stand out and help maybe figure out something or something.
Good. Anybody else have any anything to contribute, things that you're doing?
2129 here, Ultraviolet.
Hi, Tim.
Hi, how are you?
Good.
We actually fired up a Discord server, and the team is meeting 5 nights a week. Sub teams are meeting. This isn't community oriented, but it's very much about passing the baton from upperclassmen who have really carried the weight this year to a lot of people who, you know, as we always try to do, need to absorb and become a functional in their own right. So we also got to compete at Grand Forks, which was a gift. That I don't think we're feeling nearly as badly as some of the teams that were going to compete today and didn't have a chance to do that. But yeah, I'm actually very pleased with what the team is able to do online, and it's been a really gratifying time.
Good. Thank you. Thank you for sharing that. Anyone else? Well, if you have ideas that you want to contribute, you can also just use the chat function so we can all kind of see that. So thank you, Tim. All right, let's move on and let's kind of, thank you, Hannah, again. Let's talk some robots. So I think what we had first up were Wesley and Lando. And actually, Wesley and Lando, I don't even know if you're online, but this is from No Mythic, 2491. So if you didn't know, they competed at the Northern Lights Regional and were the #1 ranked team after qualifications and ended up winning the whole thing. So so congratulations to No Mythic. So Lando, Wesley, you want to take it away?
Yeah, I think I'm going to start by sharing my screen, and we have a robot reveal. So I'll play this, and then I'll kind of just talk about it intermittently. So this is our robot. Yeah, so we kind of went with our main strategy. We kind of went with we wanted a little robot that could pick up off the ground, shoot 5 balls into the outer goal, and then we wanted to make sure that we could climb very consistently, because that's like a huge point sink. And then we wanted to fit under the trench because we realized that those cycles would be a lot faster and a lot more efficient. So this is what we ended up with. We have the intake there you can see flipping out on a virtual floor bar. So it folds in and takes up a lot less space than anything else. And then the geometry works to intake balls very well. And then just to the right of that, you can see those 2 belts that singulate the balls. Those move at slightly different speeds. so that two balls coming at the same time can be separated and then go into our indexer one by one. And then the indexer, which is really hard to see in this shot, is just one polybelt loop that goes around a ramp. You might be able to see a little bit better here. So you can see the ball going in. So it just rolls through this Teflon coated ramp, and the Teflon's for helping prevent jams. And that's just one belt that we run. And then on the top of it, we have a 1-to-1 bag motor little roller that just kicks it into the shooter. So you can see it in action a little bit. So then for our shooter, we have a very basic, similar to the West Coast Products shooter, which is run off of 2 Falcons, 1-to-1 driving a shaft with our Fairlane wheel as the flywheel, or Fairlane wheel as the shooter wheel, and then we have 2 5-pound steel flywheels. So it revs up fairly quickly and stays at speed very well. And then one thing that we that helps our shooter really well is our PID loop, which our programmer spent a lot of time on getting tuned. So it always stays at the same speed when we're shooting. And yeah, it works pretty well. And then to line up, we actually never got our vision working before Duluth. We were planning on doing that by this weekend, but things happened. So as you can see on the goal there, we actually have a flashlight on the robot that just points directly under where we're shooting. So the driver just uses that to line up by hand. And they have a button that makes the robot move a lot slower. And that worked actually very well to line up. Ended up being very quick. And so for our climber, finally, we have this extension, which is made of just different sizes box channel telescoping. And then it's lifted with constant force springs, which you can see there. And then we just have one string that runs all the way to the top that spools at the bottom on a 775 spool. So we control it by unspooling it to let it extend with the constant force springs. And then our hook there is attached. It's not rigidly attached to the extension, so it comes off by lifting. And that's attached to 4 strings that go to each corner of the robot. And those go to their own spools, which are actually run off the drivetrain on a shifter. So as you can see, once the hook lands, it detaches, and it's just those 4 strings. And then we actually engage the power takeoff to shift the drivetrain into climbing mode. And then it spools the strings from that. So yeah, that's about.
So a few things actually that Nando touched on a bit with this. He was talking about the flashlight and the shooter. So ideally, if our season hadn't ended, there were a few things that we're going to change. So we're going to try to get vision to line up. Another thing is our indexer currently, it's all just done by hand pretty much. So we're going to take one ball and to manually space it. So we have had some issues with jamming on there. That's why we have the Teflon, because the Teflon really helps out with that. But ideally, we were going to use sensors to space, to just automatically space the balls. And that should have improved our cycles a lot, but we didn't never end up with time to do that. And another thing is, if you see our climber is made out of aluminum box channel, the plan had been to swap it out for round polycarb, because if you were at Duluth, you might have seen our climber got stuck a few times in playoffs and couldn't quite reach the right height. So we were thinking if we could get a lighter climber extension, we'd be able to extend easier. So if we had continued working on the robot, we would have wanted to put those things on. And we also wanted to have a adjustable back on the shooter hood by Worlds, but there's no Worlds. So there were a few things like that we were going to change just to kind of tweak the robot and make it work a bit smoother.
Yeah, I think we can take questions now unless anyone else from No Mythic has anything to say.
Awesome, thank you. Questions, either audio, or here's a question: what did you use as a brake for the climb?
Ooh, okay. So that's actually pretty interesting. So originally we were just going to use a basic piston brake to like just push against the hex shaft. And we did a bunch of math and figured out that that wouldn't actually hold the weight of the robot enough. So what we ended up with, and I'll try to find a shot that shows it. This will show it enough. So you can see right there towards the right of the robot, there's a large piston pointing down. So that's actually second class lever brake. So at the other end of that black, weirdly shaped piece of metal, there's a pivot, and then it pushes, that piston pushes it down into this hex shaft and uses all that leverage to brake. So those automatically engage when we climb. And they're also, yeah, they're also engaged during the match so that we don't unspool accidentally. Let's see.
So one extra thing that we really changed this year from last year is we spent a lot more time on prototyping. So we had, I don't know if we have videos of those somewhere, but we had a lot more advanced prototypes of our shooter and intake systems primarily. So we spent a lot of time on prototyping this year. And then with the more accurate prototypes, that really kind of helped us get to this.
I think I have videos in here. So we had this shooter prototype.
Lando, you did stuff with the intakes. This is a good question for you.
Yeah.
Figure out the geometry for
Here it is.
which will hold that.
Yeah, so this is our intake prototype.
Lando, you did stuff with the intake. There's a question about the geometry for the virtual 4-bar.
Oh yeah, so 1 second here, stop sharing. How did you forget the geometry? So we used a sketch on SolidWorks and basically took the geometry from our prototype and put that on with like the geometry of a robot. And then we kind of figured out where we wanted it to fold in. And we made like this geometry sketch. I should have opened SolidWorks, but it's probably gonna take too long to show it. But basically it's just a sketch that shows that linkage. And then we took the angles from that and did some mathy things with that and sprockets to, yeah, to figure out the linkage there. Oh, thank you for that compliment. We have a sponsor called Twin Cities Plating that anodizes all of our metal parts, and they make our robots very beautiful, which is wonderful. I almost got this pulled up. Share my screen again. So it pulls up. Oh, that's the wrong one. Yeah, so this is our linkage. It's very messy right now because we also had to figure out like motor placement and stuff. I'll turn that on. There we go. So basically, we drew out where the rollers needed to be, and then drew out where we wanted it to store, and then we kind of use this. I think it's something about like that angle versus that angle. I don't know. I forgot how we did it, but you make this sketch kind of thing, and then there's a way to figure out the sprocket sizes from there. But yeah, we use SolidWorks sketches for most of our geometry because it's very useful.
Good. Thank you, guys. We should probably move on. So
Yeah,
appreciate it.
yeah, thank you.
Congratulations again. So why don't we move on now to 2883. So that's Team Fred. Carissa?
Hello. So I don't have anything quite as fancy as they did. I just have some stats and some pictures, but our robot, we were able to compete at Great Northern, and then we were going to North Star this weekend. But so Great Northern, we ended up losing out in the semis, which that was okay. It was really fun, and it was a really tough competition. So I'm gonna share my screen. I have some pictures. Okay, so here are some CAD drawings of our robot. So right here you can see we have some power cells in there. We can fit 5 in there. Here's our climber. It's a 3-level tubing that is controlled by a string. And some stats, we have 6-inch pneumatic wheels. Our chassis is a Versa chassis. We have a 6-wheel tank drive. Our gearboxes for our drivetrain are 3-sim ball shifters, but instead of using sims, we use Falcons. And we can shift from 16 feet per second to 4.5. We can hold 5 power cells at a time if we want, and we've picked up from the floor or from the lower feeding station. Our hood right here is adjustable, so we can shoot from different angles and different places on the field, and I believe the farthest we shot from was about halfway across the field. Our turret is from Armabot, and our flywheel spins at approximately 6,000 RPMs. We were able to do everything but shoot in the logo, and we were working on something to spin the control panel, but we didn't quite get to that yet. So here is our robot actually looked like. So here's our hood and our turret, and we ended up changing these shooter wheels at competition because they ended up being illegal because they were ruining the balls. Here's our intake mechanism. This wasn't our first prototype. So our first prototype was we had these wheels here and here. Now we have this pipe around the printed wheels because we found an issue where balls kept getting stuck here and they wouldn't go all the way into our chute. So, and this was the first time we ever tested out our intake and our shooter together. And there you can see the old intake with the wheels here, and the ball got stuck. Here is one of the first times that we tested out our shooter. And if you were at Great Northern, you probably heard a really loud shooter. That was ours. You could hear it from the pits sometimes because it's pretty loud. Here's a video of one of the first times we climbed. And our climbing, it takes a little bit to line up because this hook right here is like, it's really small. So we were going to try and improve that and make it bigger because our drivers were having trouble lining up pretty fast. So and here's some close-up pictures of us climbing. So our hook is around the pole and we get up off the floor. And here's an example of one of our autonomouses. It's the one that we usually stick with. We shoot 2 balls up into the high goal and then we pick these 3 up. And we do have a couple other autos. So we do this one, and then we have one on the other side of the field, and then we have one in the middle. But most of that has to be changed because after GNR, we worked on switching up some stuff. So we switched our shooter motors from 775s to Falcon 500s. We actually ended up turning our turret all the way around. So now we shoot off the back and harvest from the front. And our shooter wheels were switched to Coulson's, and we also looked into improving our climber hook, but we didn't quite get to that because our season got canceled. So that's all the examples that I have.
Thank you, Carissa. There are a couple questions in the chat. So one was about how often did your team utilize your shifting gearboxes this year, and which situations did you use them the most?
So I'm not entirely sure how many times we used them, but I know if we wanted to be able to drive wherever we wanted to, we would shift because we have the ability in low gear to actually push a robot aside. So I believe we used them as much as we possibly could.
Ryan, you had a question too. Do you want
to? Yeah. So you talked a little about your autonomous. When you were creating your paths, did you just control the motors based off of time, or did you use some sort of pure pursuit or path generation?
Use path generation.
We were playing a little bit with path generation, but and most of those were more using the gyro and just encoder values. So I guess it'd be kind of manual path generation, but they weren't time based.
That's cool.
Good, thank you. Any other questions for Carissa in 2883? All right, Carissa, thank you very much. Okay, now it is time for our first trivia question. And Lori, tell us what we're giving away. Can't see.
Well, I seem to have a large number of volunteer shirts. The limited edition 2020 Infinite Recharge volunteer shirt. So, yep. Answer the question, you get a shirt in the mail.
Okay, so here's how it's going to work. I'm going to give you the question in the chat, and the first person to get the correct answer in the chat is the winner, all right? And then we're just gonna move right on to our next presentation, but here we go. All right, here's the first question. You ready? All right. How many FRC teams are there this year in Minnesota? All right, Lori's gonna figure that out, and then we're gonna move on to the next presentation. So that's 2823, the automatons. Zachary, Greta, Tristan?
Yeah, so we have a slideshow and, oh boy,
and slow internet.
Oh, we're frozen.
Cool. Well, message Zach and see if I can get him to share those slides with me.
Do you have the slides, Tristan?
No access to that.
Yeah, I should. I don't have the videos though.
All right. Are they embedded?
I have the slides, but most of the videos are on Zach's computer.
Do you want us to move on to another presenter?
Yeah, why don't you just start? I'll try to get in contact with you.
Yeah.
All right, so we'll come back to you guys. Is that okay?
That also, yeah.
All right.
Yeah.
Good. Okay,
Thank
that's
you.
fine. No problem. Just let us know when you're ready. You can just let me know through chat when you're ready.
Yeah. Thank you.
Okay. Why don't we move now to Ryan Lester from 7849.
Hello, my name's Ryan. I'm from 7849. We're the Gear Techs. I don't have any fancy robots to show you. We're in our second year here at Moncouch Prep Academy, but my background behind me is what I'm going to show off today. So as you all know, there was the grant that went out for field perimeters, and we were fortunate enough to receive one of those grants. And so I'm going to kind of show you just a little bit about what went into that and where we got to with all of it. So I am going to, let's see, nope, I don't want to do, let's see, I want to share with you my screen. And I'm going to share. All right, give me just a second here. Okay, so this is our second year, so we're pretty light on help, but we were lucky enough to get support from a lot of different people. So first of all, we got support from the Emperors. They allowed us to use, they didn't allow us to use, they cut all of the faces for our field elements that we built. And then we got some help from some engineers from some engineering students from St. Thomas University to help us build all of our field elements. And so we built all of our field elements, and then we were lucky enough to get support again from the Minutebots. The Minutebots built the giant center structure. And then right before everything came to a crashing halt, we had everything set up. So about a week before everything came crashing down, we set everything up in our dome. And so for this year and next year, we'll have our dome available for the field to be set up on. And then hopefully in a couple of years, we'll have a brand new facility where we'll actually have the field living year round. So we're hopeful for that in a couple of years when our new facility gets built, and it'll have 4 rooms around the outside of it for STEM classes, and then a permanent space for the field. So this is our process that went into it. We had some help from No Mythic. You can see a No Mythic shirt right there. And then we had our team kind of put the floor down, put the tarp down, and then we were lucky enough the week before quarantine started, we got it all the way set up, and we were able to have one full practice with both Mounds Park Academy and Trinity came over and helped us set up that center structure. and we were able, I can't find the video that I had of it, but we were able to get one practice in before we got completely shut down. So we look forward to many years going forward. So anybody on the east side of the river is welcome to come over and share and enjoy the field. It's all boxed up for now, but we hope to have it out. And if anybody is looking to use it, it does take quite a bit of time to set up, a lot more time than I would have thought, but we are willing to transport it to other places if you need a field perimeter or want to host an event in the next few months. So it's not permanently set up at our place right now. So
Awesome. Thank you, Ryan. That's great. So what is your plan moving forward? Is it going to be, are you going to be putting it up in that dome at a certain time and then?
I'm sorry, can you say that again? I hit the wrong button. I muted
I'm just
me
wondering
instead.
like what your plan is in terms of like during the course of a season. When will the field be up in the dome? When, that kind of thing.
Yeah, so this year we got off to a late start just because of all the issues that came along with delivery. So we were open, this year we were open just 2 weeks ago. But our hope is that once seasons roll around, as soon as we can get the structures built, once the plans come out, we'll start building those structures. And as soon as those structures are built, it'll be open. And for now, it will be open once we get in there. We hold practices Tuesday, Friday, and Saturday. And so it'll be open every Tuesday, Friday, and Saturday for teams to use. We do ask for $50 donations from teams that can afford it. We do realize that some teams are have more funding than others, and so we don't want that to be a limitation. So we do open it up to everybody. We just ask for support with financing.
Yeah, sure. Thank you. Good. Mm-hmm. There was one question here. Is your team planning to host mini regionals?
We're hoping to in the coming years. I don't know about where we're at right now just because of spacing and everything like that, but we do hope with our new building to host some mini regionals and some and to do some bigger things to become a center, not just for FRC, but all the other first competitions, nice. Especially with our new space that we're going to be having in a couple of years.
Mm-hmm. Could you, and maybe like a final question, could you tell us kind of how, even though you only had like one practice, I guess, in the facility, what kind of impact did you see in terms of your own team? Unfortunately, you weren't able to compete, so we haven't been able to actually see you in action, but
yeah,
how helpful was it? Or
yeah, it was great. We were really looking forward to being able to use it. But our team was really energized to be able to see in that one practice the other two teams that were there. And it was a great opportunity for us to bond, especially for a young team like us. We actually had almost entire turnover for our team this year. We only had about 3 returners come back from last year. And so it was great for them to see it. And we're really disappointed that things went the way that they went with this virus, but it was a great opportunity for us, and our kids were really excited for it. So
good, fantastic. Thank you very much. So just a reminder again about these fields. This is the one in St. Paul. There's one in Minneapolis, the Mura field, and then up in Duluth, the Arrowhead Robotics Coalition has got a field up and running. And then there'll be 2 others that'll be coming online, one in Becker, I believe, and the other one in Byron. So hopefully this will be of real benefit to teams throughout the state. So this is great news. Thank you. Why don't we move on now to Blue Jacket Robotics 5464. Jeremiah, are you there?
Yes, I am.
All right, take it away.
So this year, our team made a robot that could basically shoot in the high goal, do the control panels, and climb very consistently. We competed at Lake Superior, where we earned the winner blue banner and we won the regional for the first time in team history, which we thought that was very great. Only for the next Thursday to find out that the season has been suspended and Worlds has been canceled. And that's pretty sad. So with that, I'm going to share my screen and share my screen and pretty much go show you some stuff on our robot. Bear with me here, sorry. So our robot's name is Big Iron, and pretty much here we have our climber, our control mechanism. Our intake is based off of mechanism wheels that could go down when we need to use it and go up when we don't, to prevent any damage from happening to that. We have our inner intake, which is made of these orange belts that go up to our shooter, which is a dual wheel shooter, and it has the hood that can adjust. Our control panel mechanism could just drive up and spin it, which we have not really used it in any competitions, but we practice with it. And this year was our first year experimenting with the Limelight. We had many ups and downs with the Limelight. Pretty much our programmers spent a lot of time on the Limelight and the color sensor for our color wheel. And we do have blue LEDs in our robot, which I think is a pretty cool feature. And then there's us doing the control panel and our color sensor right there. And there's a better view of our shooter mechanism. And our climber is based off of our, pretty much our 2018 style climber, except instead of our scissor lift, which we use in 2018, it's on a linear motion kit that would go up. Then the hook would detach, and then there would be a winch drawn by a old boat winch that would ratchet, so it would hold us in place. The only thing that would make us fall is if there was a fault with the ratchet strap that we used. And there's a more final product, and there's our climber mechanism right there. And here's our reveal video, which this is actually the first year we have ever made a reveal video, which I feel it's pretty cool that we did. But those LEDs though. So yeah, and that we can shoot from behind the trench run on the opponent's side of the field. And there's that's how our climber works. We just go up and we hook it on, then we just climb. Yeah, one of our main problems this year, especially if you were at the Lake Superior Regional, was sometimes when we did the intake, our ball wouldn't go in 100% of the time. And we countered this by cutting off part of the side of the intake. And that helped us throughout finals. And our autonomous was on point 100, well, mostly 100% of the time. And yeah, it's pretty much our robot this year. And I'm gonna stop sharing right there. All right.
All right, thank you. You see the question in the chat? How did you power your poly belts?
I can answer that one, if that's okay.
Yes.
So,
go ahead.
So we use one of the gear motors, the PG motor. If you can pull up the side, it's like we used it's like the infinity belt, but to power everything to go the same direction, we used a motor on one of the belts, and because there were 3 different belts, we actually powered one belt, and then the belt there's a smaller belt that was connected and it flipped. I can't screen share because I'm on my phone, but could you pull up like a picture of the side of the robot, Jeremiah? Is that possible? It's on the other side. So I think if you could zoom in, maybe you can kind of see it in some spots. Yeah, if you pause it right there, you can see that, yeah, right there, there's a round belt that's driving each different belt. So the top belt is driven by a motor, and the motor is actually off to the top left corner of the screen. And then on the right side, you can see the belt that connects all of them. We had to do a twist knit to make sure they all went the same direction to bring everything up to our shooter.
Great, thank you. Any other questions about the robot? Did you guys want to talk about your outreach at all? I wasn't quite clear about whether you want to do that.
Oh yeah, our outreach. I also have a super cool photo on this one where we actually got to deliver the game ball to one of our basketball games, and we got our activities director. Oh wait, I'm not muted. Sorry. Yeah, our activities director came up to us and complimented us on how ecstatic the crowd was to see that. And we had our pancake breakfast back in November, and that was a very good turnout. We were going to have our craft show next weekend, and we were going to bag foods at Cub Foods, but we all know what kind of happened there.
Yeah. Good, thank you very much. All right, any other questions for Blue Jackets? Congratulations again on that Lake Superior win, that was great.
Thank you.
Fantastic. So, okay, so let's tell you about the first trivia question. So the correct answer was, at least according to the program booklet, 224 FRC teams in Minnesota. And Lori's got so many shirts, she's going to give away one to a mentor and one to a student. Is that right? So Tom and Hannah both came in at the same time with 224, and Avdo from 3750 is also there. So I think she's going to contact you by chat to get the shirts to you. 2023, how are you doing? Are you ready? Greta?
Almost, but we still need a little more time. We're still getting all our videos in order.
We can start. It's fine.
You sure?
We've got most of what we need, I think.
Okay.
Oh, do we?
Go for it.
All right. So Tristan, do you want to?
Yeah. I've got some of the videos here, but we can run with what we have. If I can figure out how to share my screen here. Oh, there we go. Can everyone see that?
Looks good.
All right, sweet. So yeah, we whipped together a little presentation about our robot and our design process here, along with some videos to show you of the robot. And yeah, so I'm Tristan. I was the operator this year and the build captain. And to start, we got a video of our auto here. There we go. So the auto, it grabs the 3 balls from the trench and shoots, or 2 of the balls from the trench and shoots 5 into the high goal. Later in the tournament, we adapted it to actually use the vision tracking. So it locks onto our target in both the X and the Y direction and nails the shots pretty consistently.
And actually, we were really proud at our Duluth Regional. We won the Autonomous Award, sponsored by Ford, for a lot of the great work that our programmers did with limelight targeting. By the end of the regional, pretty much from anywhere in the midfield, we could line up and hit even some inner port shots just with our auto targeting. So we were really happy with how that turned out this year.
Yeah, that was really awesome. And there's a couple pictures of our robot, a CAD file, and then how the robot actually ended up. To start with our kind of chassis and superstructure, it's just a kit of parts chassis with 6-inch high grip wheels. We didn't have a ton of band build with this year, so we just went with the kit of parts chassis to save some time, which is what we did last year. And I don't think any of us regretted it. It works really great for us and was pretty fast. We ended up switching from sim motors to 4 Falcon 500s, mostly as a weight saving measure, because we were really close to the weight limit. We saved like 6 pounds just switching to Falcons, and they worked awesome. We had a lot of tipping problems really early. We almost tipped over whenever we'd accelerate, but we shifted around some parts like the battery to rebalance our CG, and also added a ramp up on the motors, which allowed us to accelerate pretty much full speed with very little tipping problems. And then the superstructure that you can see here is just made with the 1x1 Versa frame from Vex. And then we have some cross plates here designed by Zach to fix some wobbling issues that we had early in the season.
It was pretty jelly.
Yeah, it would notice we wobble back and forth when you drove, which was kind of nerve-wracking, honestly. And then for our ball sorter, we had our washing machine, which some teams would call a carousel. We spent a ton of time prototyping, trying different iterations. We probably tried 5 or 6 different versions and fine-tuned, 10 or 20 different variables to get this thing pretty much jam-free. And it can hold 5 balls. It can actually hold a lot more than that, pretty much as many as you can fit in the chassis, which obviously you can't do in a game, but it's got pretty big capacity. And then it was relatively jam-free, but our programmers whipped up some code that measured the encoder values compared to our set point. And if it detected a jam that way, it had reversed slightly, which pretty much solved any remaining jams and allowed us to get a really smooth, continuous flow of balls through there. And then just the mechanism to get them out, we call the uptake. It's just a polycarbonate box with a poly belt that runs through the middle and some Teflon tape. There's a ramp on the bottom of the washing machine that just kind of bumps them up into there, where some wheels grab it and bring it up into our shooter. And we use Teflon tape to solve like dozens of jams. It was kind of a miracle worker here. There's kind of a joke that there's no problem you couldn't solve with Teflon tape, because it just was so good at resolving jams. I think Zach can talk a little more about the shooter here.
Yeah, so this is when I spent a lot of my season curled up on my couch and watching Netflix catting. We overbuilt our shooter, and we're pretty happy with what that did for us for the rest of the season. So we had 2 Falcons running the shooter, stepped up initially at had an abduction of 1 to 2, which we later brought down to just 1 to 1.25, which gave us a lot more accuracy and helped our Falcons spin up a lot faster. We were using 6-inch Coulsons at 2 inches of compression, which we thought gave us just about all the power we needed. We too bought the Armabots turret and designed an adjustable hood so we could shoot from anywhere from right up in the target zone to from behind the control panel. Which hopefully we should get some video of. Yeah, we had a great spot for our limelight, and we're pretty happy with just the quantity of balls we could get through the shooter going at once.
And 2 brief notes on this. Originally, our strategy was to shoot from behind the control panel. That's why the robot's so tall. In practice, it works really, really well. But when we got to tournament, the balls had huge gouges out of them, and that meant that they compressed a lot faster, and we couldn't get the same velocity and ended up dropping shots a lot. And then just to touch a little bit on the control systems here, we've got a limelight on the front that's mounted at an angle, and that allows us to take both the X and the Y position of the high goal. And we use the X position to rotate the turret, and then we use the Y position to set a position for the hood, which then informs the shooter speed. So we're always pretty much shooting a straight line to the high goal no matter where we're from, which allows us to nail the inner port quite a bit. And then we can shoot from pretty much anywhere, as previously mentioned. We were supposed to have some videos, but due to the aforementioned technical issues, I think I
Video at
have,
least.
what?
Do you have the long shot video at least?
I should. I have a photo that should be a video, but Google Photos is not working great. I have a shot from the initiation line here, so that's us shooting from the initiation line right up against the target. And then for a little bit of perspective, our hood can tilt forward far enough to make the shot that you're seeing right now, if I can get it to load. Let's see. Let me just try this once, and yeah, it doesn't look like it's gonna load. But we could consistently get about 4 to 5 shots into the high goal with good quality balls. And then this is one of the little surprises that we had, well testing, which is just one of our favorite moments from the season that we wanted to share.
Oh wait, the video doesn't work too well on Zoom. But yeah, it got caught back in our shooter, and we had to take the entire thing apart to get those beautiful compressible balls out of there. So yeah, I think we can move on to the intake, which was just entirely ripped off of our 2017 selves from front to back. I just looked at the CAD for our previous one, and then pretty much we had actually a bunch of people work together to just recreate that CAD with different dimensions, which worked absolutely fantastic. The main iteration throughout our season was we added 2 more compliant wheels at the top because we would have a lot of issues with balls stalling at the top of our intake, and just adding a few more compliant wheels up there really just kicked them back. We were pretty dang happy with how good the intake was from a touch-it-own perspective within the bumpers, but the one major iteration we were considering is possibility of an over-the-bumper intake or a roller bar to really get the full width of our bumper as a as the zone in which we could acquire balls from.
Yeah, the primary issue stopping us there was probably just weight. We were at like 124.6 by the end of our regional. So, and talking a little bit about our climber, which gave us a lot of grief throughout the season. We have, it's just like a single stage lift, 1 static bar and 1 moving bar. We've got one motor that brings it up, and then a motor that brings the hook once it's dropped. Or that was the original plan. We had a lot of weird considerations where because of the washing machine in the center of the robot, we didn't have space to mount a climber in the center, which meant that we were really worried about getting really extreme torques when mounting it on the side, possibly upwards of 1,000 pounds, which that's what the math told us. We weren't sure how true that was, but we ended up just adding a second motor that pulls straight through our CG, our center of gravity, which eliminates a lot of those weird torques and worked fairly well. The main issue we had was that we used a Vex gearbot ratchet, one of the Vex Versaplanetary ratchets, but the part that held the spring would break a lot, leaving the ratchet not engaged, which caused us to not climb for probably 2 matches. And if you can see in the bottom right corner, what we ended up doing was we attached a 1/2-inch ratchet wrench to the bottom, to the end of our climber, and attached a plate to restrain that. So that worked as the ratchet to prevent us from falling back down while climbing.
Yeah, and then I think we just have one last picture of us.
Yeah. So that is us climbing with 1816 green machine there.
All right. Yeah, Versa wrenches do kind of suck.
Yeah. So yeah, if there's any questions, that's all I have for the presentation.
Good. Questions? All right, good. Thank you, guys. Appreciate it.
Yeah, thank you.
All right, thank you. Okay, we're going to move to 1816 yet next, but our second trivia question. Are you ready for it, everybody? Here we go. How many Minnesota women have received the Woody Flowers Finalist Award? And while we're getting those answers, let's go to Green Machine. So Tenzing, Parker, Ryan.
All right, sounds good. Do you guys see my screen?
There it is. Yep.
Cool. So I'm just going to be going through some of our slides. So here's our presentation. That's our team mission. So this is the CAD for our robot. That's just what the full overview looks like. So for our drivetrain, we went with 6-inch traction wheels with an 1/8-inch drop. We used 4 Falcon 500s, and we geared it to go 16 feet per second because we thought that would be a good speed to traverse the field, but also still have all the control we needed. One interesting thing is that we actually had our electronics upside down, so we could access them from the bottom of the robot if we flipped it upside down. But that just allowed us to easily access them, but still use that space on the top. So this is our ball management system. We like to call it the Spindexer. It's pretty similar to the last one. It's not in the CAD, but there's a little piece of tread that goes off that hex shaft, which actually pushes all the balls up into our elevator system. And you can see it's driven by that first planetary right there. And there's chain that runs under that aluminum plate to power that hex shaft. So this is our turret, which allowed us to do a lot more complicated autos and gave us much more capability, a much better capability to shoot from all different parts of the field. So here you can kind of see that gearbox, which is designed to rotate the entire turret. We had almost 360 degrees of rotation, but you can see we had the encoder off to the bottom. It's basically on the bottom of the bottom right of the gearbox. And one unique thing is that it's a 1-to-1 off of our actual turret, and that allowed our programming team to not have to have any homing sequences or anything special. They could always just rely on that one encoder value to make our shots. Here you can see our shooter. So we used 2 Falcon 500s. The ratio was 1 to 1.92. So we actually went very fast because we had 90 durometer wheels. So they didn't have a ton of grip. So we just made the spinning a lot faster to make up for that. So yeah, it's backed by churros, and then there's a Lexan plate, which isn't catted in there, but which backs that to make it smooth for the balls to roll up through. Here you can see our over bumper intake. So it's just like a lot of other teams, driven by that 1775. The ratio was 20-to-1, I believe. One unique thing is you can see those little, well, it's hard to point out, but behind in the back, there's 2 like pegs that go down. Those were for, there's a bar there so that when we fold up our intake, the balls can't go out of that little space. So that basically allowed us to always keep the balls contained. Worked pretty effectively for us. So here's our climbing system. It's pretty similar to No Mythics. We basically have the 3x3 telescoping climber. We have a gearbox which has a neutral and actually ratcheting two different gear ratios. So when we push into neutral, the constant force springs can unwinch the system, and it will go spring into where we need it to be, and then we shift back into position and ratchet down to get into place. So one of the challenges was obviously being a super consistent robot. So we have a CNC router, which really allowed us to do that. So we could create all of our parts super precise and accurate to exactly what we wanted. So we basically machined our entire robot in-house. We CAD'd it all and made sure everything fit together perfectly in the CAD, and sent it off to our router and had our students cut it all out, make the cam for it, cut it out, and then assemble it. So that was pretty fun. Ryan can talk about the software.
Yeah, so I'll talk a little about the software part of a robot. So this is one of the more more standing out part of our software was continuous turreting. So we'd use the gyroscopic functionality of the pigeon, and based off of our initial orientation, we continuously adjust the turret so it'd always be facing towards the goal. And what that would do is ensure that the vision frame is always with looking at the goal, so then whenever the shooter needs to shoot, it has minimal adjustment, which allows for higher accuracy. And yeah, so autonomous mode this year, during the off season, we worked a lot on getting trajectories and splines to work. So we used some of Cheesy's math, which involved a lot of linear algebra libraries that would allow for the generation of a spline, which is some sort of mathematical function that plots dots based off of a specific set of points that we already know and would draw some curvature. And what that would help us with is really precise autonomous. We could practically drive anywhere where we wanted, and we could plot that on a graph, and it would drive there. And that helped for really consistent autos and allow us to score a lot of points. Another thing is parallel actions. We moved away from the WPI-lib command-based sort of structure and code and work towards sort of an action base, which is a layer of abstraction added to our code that would sort of have each subsystem class have its own action and have one class that would call from each action from a looper. Yeah, that's what the action-based code is. If you want to move to the next slide. And another thing we worked a lot on is vision processing. We decided not to use a Limelight this year, and instead used a Z mini camera, which is a stereoscopic camera that allows us to get distance, paired along with the Z Jetson Nano, which would allow us to process so the vision frames more quickly. I'm not too accustomed to this, but since we have another programmer that works more with vision, but all in all, the Z camera allows us to get the distance from the goal, and based off that, we would be able to adjust the wheel velocity. So then we'd always have that smooth curve that would always hit the inner port of the goal, top goal. And also using OpenCV library, we were able to do some sort of shape detection with the goal, so then that would always be consistent, and we'd always be able to align the shooter directly towards the center of the goal, and allows for consistent shooting. And another thing is sort of a quality of life thing for the programmers is that we was a thing that Ian, our vision programmer, made, was calibration via the shuffleboard. So then whenever we're on a different field, we'd be able to calibrate the camera based off the different environment, because like all different fields have different light, pollution and all that stuff. So this really allowed us to be able to use the camera to the best of its capabilities. And this is another thing we worked on last year and sort of developed it more to a higher level during the off season, was Robot Factory, which is just another layer of abstraction. We just focused on abstracting our code as much as possible, keep just adding the layers of complexity, so then you can do a lot more stuff and more or parallel actions, doing one action, but another part of the code is processing another action at the same time. And Robot Factory is sort of this configuration system that would allow us to use one code base for various different robots. We'd be able to deploy this code to our 2016 robot, 2018 robot, 2019 robot. And what this is more flexible development and more rapid development as well. And another thing is action-based program, which I talked about in our autonomous modes, which is, it's just more reliable, I think, compared to command-based programming, which you just need to code a ton of commands, and it's just really superfluous, and it just expedites our development and iteration of programs and our autonomous creation.
And that's it for the robot presentation. So I think questions.
Any
now.
questions? Yeah. Robot Factory is something our one of the programmers on our team, he's not here right now, created. It's just basically a class that creates instances for all the hardware. So it's like the Victors, which we used last year, the Talon FX it's just a class that is initializes all that during robot initiation.
So we actually, for preloading, that was something we were going to work on for this regional for this week. We just didn't have time, but so at the regional at Duluth, we just held them all in the Spindexer, but eventually we were wanting to preload into the elevator so we could get off a lot more shots quickly.
Any other questions for the Green Machine? All right, Parker, Ryan, thank you very much. All right, we're going to move on to Jesse Frost next. I just want to give you the answer to the second trivia question. It was 10 women from Minnesota have won the Woody Flowers Finalist Award. So seems kind of low to me, just kind of saying. So Jaden, Gwen, and Annie are going to be receiving some shirts. So next question is coming up next, but first we're going to go up to Cass Lake. Jesse, you ready?
I think so. Can you hear me?
I can.
All right. Well, I'm going to show you on my phone, because I don't have a nice slideshow, but I'm just going to do a little walk around of our robot this year. Actually, both of our robots for our two teams are really similar, so I'm just going to do the one. I think that's broadcasting there. It looks like it is. So we did a lot of new things this year that we typically haven't tried before. We had a lot of new members on our team, a whole new drive team on both teams. So we had some really dedicated new kids, so we were able to try some new neat stuff. So our drive family went with a AndyMark regular kit of parts, but we upgraded to the 8-wheel drive kit on 3134's robot, just to kind of ease the pressure on going over the bump. So that was something new that we played around with a little bit. We had several iterations of our intake system here, but a lot of 3D printed parts. We had a bunch of 3D printers in this year that we're starting to be able to utilize a little bit more. The poly belt from McMaster Car, and we got some 775 Pros driving the intake. So We got 10-to-1 gearboxes on those for the in, and that drives a couple chains that bring it down to the front. We just tried using the belts to drive it, the poly belts themselves, but you couldn't get enough traction on them, so we switched out to chains. And then 775 Pro to bring it up to the top. And the gates belt is actually what brings the ball up to the top where our turreted shooter is. And we were in the process of changing a few things after Duluth to get ready for our Minneapolis event. One of them was to add a flywheel to our shooter, so we have a steel flywheel on there just to maintain some consistency. We also added another Neo to the shooter, so it's a double naked Neo shooter run by our Limelight, basically, to track the vision or to track the target. And that'll actually, we have a program to judge distance to target, and that'll variable the speed on it, because our hood itself is not variable, it's fixed, but our speed on our wheels is variable according to what the Limelight puts out. And then our turret moves with this compliant wheel mounted to a snowblower motor, which actually seems like it worked pretty good. And it's got a couple stops in the back here. These little limit switches. We didn't have an encoder on the turret, but we had some stops to hit these limit switches that would prevent it from overdriving and pulling wires out. We have our Wheel of Fortune manipulator here, which is one of those new, I think it's Johnson Electric hatch motors with a 3D printed case that came with the kit of parts. So we just had a programmer would look to the right and you drive up and manipulate it, although we never did get the opportunity to try that in competition yet. And then our climbers are all every bot climbers except ×2. So thanks for 118 for providing that resource. Did a couple little things on our own to make them a little bit different, but basically poly cord would help raise them. It's a PVC tube inside the metal, and we'd unspool the winch, and that would allow them to raise up. We have a double hook on the top, so you could hit it from the front or the back, depending on your orientation at the end game. And then you'd wind it back up with a, we just have a sim motor hidden in the wires here, run into a sprocket that would wind them up both evenly on each side. We were in the process of changing some things on that for the Minneapolis event too, where they would actually shoot up to deploy, so you didn't have to wait for it to unspool. But you know, they kicked the kids out of the school, so the kids haven't been able to work on it. But we still hope to do some off-season events. Hopefully everything settles down by then, and we're able to do the Gitch over in Duluth, and then the one that we help host, the NMRC event in October. So hopefully this robot's got a few more plays on it yet. That's about all I got, I think.
Thank you, Jesse. Alex has a question for you, Alex. Alex, are you there?
I think he typed it in a chat.
Okay. It's about turret values.
Yep.
Yeah, did you ever find your wheel slipping on the turret or the values getting off, or did you just run it completely manually?
Well, we didn't run it manually. It was run completely by the Limelight, so there wasn't any values for it to gather. There's no, like I said, there's no encoder on there. So the Limelight just kind of scrolled back and forth until it acquired the target, and then it would try to maintain a lock on the target. And that was all through the programming in the Limelight. I'm sure there was some wheel slippage, but it didn't seem to affect anything. One thing that I will say, it wasn't very fast. Some of those turrets were really fast. Ours wasn't quite that fast, just because of the reduction on that snowblower motor. But yeah, it was kind of a clever way that one of our former students, now a mentor alum, came up with to solve that problem of that turreting. Also, we got all the stuff that we can build this in-house. So, you know, student and mentors helped with all the design phases, and we have a pretty nice shop up here in our build space that we were able to CNC router out the parts just to be able to make something accurate that's going to be consistent. This is our first year being able to use that type of equipment in-house, so that really helped us make that step this year into a higher level of competitiveness.
Good, thank you. Jesse, thank you. Any other questions for Jesse? Again, Jesse, congratulations on your Woody Flowers Finalist Award at Lake Superior.
Yeah, thank you.
That's awesome. Very
cool.
good. Well deserved. Thank you. All right, so we're going to move on to the Fire Bears next, but we got our third trivia question here. Are you ready? Get your chats ready. Here we go. How many Minnesota FRC teams have won the Regional Chairman's Award? All right. As those answers are coming in, I'm going to turn it over to Tom Lageson, actually another Woody Flowers Finalist Award winner this year from Northern Lights. Tom?
Thank you. So I'm actually going to turn it over to our head captain, Gwen Lau. I do want to say before I do that, you know, it's been an exciting year, I guess, for us, our team. We did a lot of things, a lot of outreach events, and we were really pushing for the Chairman's Award. Unfortunately, everything got cut short. But I do want to say thank you to, you know, the student leadership on the Roseville Fire Bears this year. I think we've got 9 seniors, and they really came through, and they really provided a lot of leadership, student leadership, and so I was quite happy with that. They stepped up and did a lot of things. So sometimes it's easy to forget, you know, that you know, behind every great team, I think there's a lot of great students. So with that, I'll turn it over to Gwen. So Gwen, you want to take over?
Yeah. Hi, I'm Gwen from the Fire Bears 2846. We're from Roseville. We're going to show you a couple things. We got our chairman's video. I'm not sure if the videos have been showing sound, but we'll try to play it. And then also show off our technical binder, which is something that we tried this year, our first time doing it. So I'll show you that first. I'm not exactly sure how to do screen sharing. Yeah. So this is our technical binder. Here's a picture of our team. We have about 40 students on our team this year. Table of contents, strategy. So on the first weekend of the season, we came up with this list of things that we would focus on during the season. And our 2 priorities are getting power cells into the upper port, which we ended up shooting them, and climbing. So we made a climber for our robot as well. So this is a picture of our robot. Her name's Gary. We named our robot that because our first prototypes looked a lot like a snail. And Gary is a very famous snail. So we have here on the top are our climbers. They're kind of big. That's so that our drivers don't have to be super accurate to actually get in onto the bar. We can just run up there and get it up. They're powered by linear actuators, so there's 2 of them.
Hey, Gwen,
That are.
can you actually scroll the document? Right now, it's just not scrolling.
Oh. What do you mean? What is it showing?
It's showing the technical binder right now, just the first page.
Oh. I will see just a second.
There you go.
Okay.
There it is. Thanks.
So here are our climbers. There's 2, 1 on each side, so that when we go up ourselves, we're balanced. Yeah, so they're powered by linear actuators, and then we have our storage here, which we can show a better picture of later, but there's 5 balls that are stored vertically in a circle, and then it rotates. And over here we have our shooter, which is 1 wheel, pushes it up against this back board here, and then it shoots out that way. And then here's our acquisition, which has spinny rubber stars that pull it into this orange belt, bringing it into our storage. So we did a lot of prototyping this year. Just some pictures of that. Our power cell acquisition with the red spinning stars is almost the same as our acquisition we used in 2016 because that worked really well for us, and it worked really well for us again this year. It centers the ball into the middle so that it can be brought up into belts that are around this area on our robot. Yeah, so if the ball comes in from this side, if it's rolling in, then these stars will bring it into the center and bring it this way. Our storage, you can kind of see in this picture here, it's really small. I don't know if I can, oh, that did not work. Sorry about that. Yeah, it's kind of hard to see, but these 5 balls here are stored vertically, and then this shaft that it's on spins to push them into the spinning wheel that shoots it. Lots of spinning wheels. And this is our loader belt that brings it into our storage, which is this thing from our acquisition. So at the beginning of build season, we were looking a lot on this Desmos trajectory thing that someone made, which kind of shows what angles we can be at to get the ball into the power port. So there was lots of different angles we could use, different speeds we can use to get it in. So that was a fun tool that we utilized. Our climber, we're pretty proud of this. It worked every single time. It's very consistent. So a linear actuator, or 2 linear actuators, because there's 2 of these on our robot, bring this hook up into the air. And then when we want to actually pull ourselves up, it goes the opposite direction. And these hooks actually tilt down because we were very close to the height limit. So that saved us some room on our robot. And they're just popped up by springs when they start going up. Our chassis here has 6 wheels with 6-inch pneumatic tires. That was so that we could go over bumps easier because the center of the field was very bumpy. That's why we chose those. And then we got our 4 motors here. Our autonomous, we had actually 7 autonomous routines, but we only really used 1 or 2 of them because they were pretty consistent. So we just used the ones that worked best. We shoot 3 balls and then back up off the line. That was what we usually did. Yeah, so that's most of our technical binder stuff about our robot. And we actually had the opportunity to compete at the Northern Lights Regional, which was great, an amazing opportunity. And we ended as finalists with Rogue Robotics and TC Robotics. So here's a picture of us. Is it showing? I think, yeah. So here's us climbing. That was one of our proudest things. We got a lot of climbing points. So yeah. And then I think we'll try to show our chairman's video. I just have it up here, so I will play it now. Years ago, we started out just building robots. Now we build more than that. We build inventors, innovators, creators, engineers, and leaders. They're learning some skills, impacting communities, and making a difference. We believe that education is key to building a better future for everyone. Through the development of our team's core values, resilience, caution, patriotism, and sustainability. We learn from the best. Our mentors are Barry Scott and Okay, so I don't think the video worked very well. Sorry about that. Um, but ooh,
Glenn, if you can send the YouTube link and put it in the chat, then people can see it.
okay. How do I exit this?
There you go.
Okay, yep.
Great. Any questions for Glenn, Fire Bears? I think a couple were answered in the chat, so I think we're good.
Yeah.
All right. Thank you very much.
Yeah, thank you.
Thanks. All right, we're gonna move on and we're gonna go up to Badger, team 3750. Alex.
Yes. So this year we decided that we wanted to go low right off the bat because we figured it would help us get through the field the best of our abilities. So just a kind of an overview of our robot. We have a turret run by a 775 that's hidden behind this bar. And this whole bottom part is one large gear that is cut out of aluminum, laser cut. We also used two 4-inch wheels sandwiched by 4 steel plates to help keep our inertia up on that. We used a limelight on top because we didn't have anywhere to put it down here. Otherwise the balls would hit it. And we used that for target tracking, and we're able to hit very consistent shots on that. Our climber was centered right in the middle, and our winch is right here with a string that goes under that would pull it straight up. I have a video of that here, I believe. So we used the winch to pull it out from its flat position, and then we would just let the string out, and springs would help actuate it out, and then you could just winch it right back up to bring it back down. And then we used on the winch, we had a little actuator that had a gear, and that's a little piece of chain put on a piece of metal, welded on, and that would just line up and help break the winch, where this would have the string on it that was pulling the actuator or the climber up and down. All of our wiring was underneath our robot, and we had a hood style mechanism, or like a car we wanted to do. So all of our wiring was underneath. So we were able to just have a complete flat build area up top and have complete room to build the rest of our robot and not have to worry about working around wiring and all that other stuff. That's kind of a view of it. We have a color wheel mechanism right here. And we switched this plate to be underneath. So we were actually had the color sensor on top of here, and it would look underneath, since you could view the color underneath even though you couldn't run it from the bottom. And we used that in one of our, or a couple of our matches. So that was really cool to be able to use that. Some videos of it shooting. And how we indexed it was, here's a kind of a view of it. There's belting that ran in an L shape, and then there's another little piece here. And this is just a ramp that helped the balls travel down into the belt, and we'd preload a couple of them, and there's a little motor over here that and there's belting under the belly pan that ran the belts together through a cross loop. So they're always working together to bring it over. And then we had here's a better view of the belting. And then there's a little kicker wheel that just span the ball up into the shooter. And we use the limelight for tracking and the speed of the wheel. So it'd get the values and then put it through its equation and figure out what RPM to put it as. So, yeah. I'm not sure. Oh, there we go.
Good.
So, yeah.
Thanks. So we got one question in the chat. How did you keep the hood latched during a match?
The hood latched. I'm not sure I understand.
Jeremiah, you want to ask that a question again?
So like for the hood that like where you'd lift up the actual mechanism part and the wiring part, you know, that thing that you called the car hood, how'd you keep that latched?
The way we put 2 bolts through each peg here. Here, this kind of shows there was 2 little or 4 pegs, and 2 of them had holes through to pin it down. And when we wanted to pin it down, we'd just bring the hood down and then put a bolt through each side, and that would hold the hood down. And then we didn't even have to put nuts on them because our bumpers would hold the bolts in during the match, so we didn't have to worry about them coming out at all.
All right, that's pretty cool.
Maisie, you have a question?
I was just wondering how your bumpers attach to your robot.
I don't have a very good view of this. I can pause this. So we had 2 U-shaped bumpers, and there's pegs on the side of the robot, and all they did was slide on, and then these 2 would actually clamp together with like a I guess I don't even know what the clamp itself is called. The ones this side would have like a lever, and this side would have a hook, and that lever would grab the hook on this side, and then you'd clamp it, and it would pretty much just tighten it, and those pegs would hold it on, essentially. See if there's so like these pegs here, the bumpers would have holes in them, and they would just slide onto the pegs there, and then latch in the middle.
Great.
But I mean, and then here's one of our autos. We had this is the main auto we used, was a 5-ball auto. From our side trench. So, yeah, that's pretty much our robot. I don't know if Abdul's in the call too. He's our main programmer. If he has anything to add, but
not really, but I think you went over how we did like the turreting. We used limelight to transfer like the amount of pixels into RPMs, and like it could follow the tape if it was within like the camera. And then for our autos, we just got into path or like path finding and like path weaving after our regional and Grand Forks. But other than that, there's not a lot that I can think of to add.
Good, thank you. Any other questions for 3750? Alex, Opto, thank you very much. I have to say, all these robots that we're seeing today are like not only amazing machines, but they're beautiful machines. Actually, if you think about how elegant they are, they're really amazing. So thank you. All right, we're going to move to Kaylee and Mechatronics, and then 2129, and then Let's see, our trivia question, Chairman's Award. Recipients, 12 teams have won the Minnesota Chairman's Award. John Stratus has already kind of indicated that on the chat, and Kaylee and Maisie actually were the winners of shirts, so congratulations. All right, here's question number 4. I hope you're ready for this one. How many students danced in the Best Spot Ever music video from this year? And with that, we're going to go to Kaylee, Mechatronics.
Awesome. Okay, so hi everyone. I'm from Team 3313, and I don't have a fancy presentation or anything, but I just have our judges handout that I will screen share with you guys. Before that, I just actually found out about this morning because it was kind of a last minute decision, but something maybe teams can do to help out with everything that's going on right now. Our local hospital was in desperate need of PPE, and they put out Facebook posts and things like that looking for it, and so we found that they actually needed safety glasses, which we have a ton of and will be able to get more of after all of this is done. So we donated safety glasses and masks as well as gloves to the local hospital. So that's just something teams can maybe look out for and do themselves. And I just have to figure out how to get this to screen share quick, sorry. Okay, hopefully you guys can all see that. So this is just our judges handout, and I figured it would be a good thing to go off of for this. So we just have this in the pits. It makes it simple for our students because then you don't have to try to remember the entire list. You can kind of use this for talking points, but then also it's great for the judges to be able to take with them and kind of refresh their memories, and also for the teams to be able to look at. On the back side of it, we have our robot and just some basic facts there. But so talking about our outreach, we just kind of have basic info here at the top. So we are very proud of having over 50% female team members, and that's been consistent over the last few years. Of our alumni, 6 of them volunteer at first events, and 80% have gone into STEM majors when they've gone to college. 100% of our alumni have gone to college, which again, we're very proud of. And we have 8 alumni who have at some point mentored our team. Some of them have now moved out of the area or whatever else, so they're not all currently mentoring, but they have throughout the recent years. So something we're really increasing this year actually is working to be eco-friendly. So we've worked with the local, I guess, like garbage company, you could call them. And so with them, we've been able to do zero waste events. So we've made our fundraisers as well as FLL tournaments that we've hosted zero waste events. Also, I think I saw Chaotic Robotics, some of their people are in the chat right now, and they started a Go Green challenge where teams basically collect as many cans as possible and then recycle those, and we've been participating in that. I think when we left school for the last time this year, we had about 3,800 cans, so we're super excited about that. And then also we're members of Project 330, which was started by another team, and it's with the goal of reducing plastic use. So we've been doing some stuff with that. So then the Pima My Pack Expo, that is an event that is for manufacturing and specifically packaging businesses. It's hosted in Chicago, Illinois every 2 years. And in 2018, our team had the opportunity to attend that event. So some of our sponsors helped us to pay for the trip, and we were able to go and then present at it just at like a booth. We weren't in front of all of the attendees, but there was 50,000 people there, and all of them were professionals in the packaging industry, which was really amazing for our students too, because we got to then learn from those people and also look at some potential futures that we have within manufacturing and other jobs in engineering. So every year our school hosts a STEAM Expo. It has about 1,500 attendees annually, and with that we get to present to people of all ages. We have everyone from small kids to high school age people all the way up to adults that come, and we just talk about our robot and kind of show off what we do, I guess, and teach them about robotics and what it is. And then something I personally am very proud of this year, because I was one of the leads on it, was we hosted our own blood drive. So we worked with the American Red Cross, and through that we were able to hold a blood drive this January. And we had 33 people come to donate, and of that collected 28 units of blood, which was really awesome. So then our summer camps. Last summer, this was our first year doing this, we held 6 summer camps, and each of those were 4 days each. And what we used is the FLL and FTC like basic robot kits. And then with those, we had different challenges for the kids, and they got to learn about the engineering and design process and all of that. And that was led by our students. And then also this line here, you see there's 35 educational, 27 promotional, and 7 volunteer events. Not that you guys are probably spending too much time reading through our essay or anything like that, but if you have seen some of our other numbers, you'll notice that these might be different than where we have other places, and that's just because on this sheet we don't repeat stuff. So like the STEAM Expo here we've done for more than 5 years, but we don't count that in any of the lower numbers. But so with that, our educational events include classroom visits, working with after school programs and other things like that, where we're teaching kids about STEM and trying to get them to do interactive activities where they are getting to learn. Promotional activities are more so like sponsor demos and other things where we're just kind of showing off what we do and telling people about our team. And then the volunteer events are things that are not benefiting our team, they're benefiting other organizations in the community. And we help out with those. And then finally down to FLL and FTC. We are very proud of all of our teams. That's our programs have grown greatly this year. And so with that, we have started 5 FLL teams and 1 FTC team. And we also share our space with several of those teams. So they meet right in our build space, which is really cool because we get to have them there with us. And then it's easy to help them because we can just jump over to their little area in our shop and help them that way. We also then mentored and assisted several teams, and we also run FLL competitions. So we've done regional tournaments as well as what we call just for fun competitions. And so with those, we just get some teams together, and then our volunteers get to practice while the teams also practice. And then finally, we've raised a lot of money for FLL and FTC. We've done that through grants, sponsors, and we do shared fundraisers. So when we host fundraisers, we also have their teams there, and then they get a share of the profits. And I guess I don't quite know how to work the chat thing very well. I see there's new messages, but I can't quite see what they are. But I think that's all I have. If there's any questions.
Good, thank you, Kaylee. Any questions for 3313? Let's see. What is your, so Maisie, was that question for Kaylee or is that for everybody?
Okay, so I think my favorite event are the FLL competitions, and that's because we've worked with so many of these teams and either mentored or assisted them throughout their season, and then we get to go actually as the judges and the volunteers and the referees, and then watch these kids compete and see, I guess, what they are able to do, which is truly amazing. And then someone else said, what are examples of volunteer events that you do in your community? So that would be, we have, they call it an empty bowls fundraiser that we do every year. So we go and help with the setup and the cleanup and all of that stuff. And then also we've helped with some events for different organizations, like nonprofit groups will help with like their banquets and things like that too. I guess my mind is kind of blanking. I know there's more, but that's what I'm thinking of right now. So.
Good. Thank you. Thank you, Kelly. Appreciate it. All right, we're going to go to 2129 from Minneapolis. Are you guys ready?
Yeah, I'm good.
Go for it.
Is that working? Okay. So I'm Gintz from 2129. I'm the CAD lead. So most of the stuff that I'm going to be talking about is designing the robot and things of that matter. So we went for eight-wheel drive pneumatic with this picture here has Sims, but we actually, in the final product, we were using 6 Falcons, and we geared those for not like high torque, but so we drive fast was the idea. We are shooting the low goal, not the high one. We have a Mecanum wheel for the intake and a hopper system with poly belts to hold that in place, to hold the balls in place, and we have vision tracking with the Limelight. So more specifically, here's the CAD model for our robot. We were originally using like off-the-shelf 4-inch Mecanum wheels, but just because of the shape of them, I think I have a picture in a second. This here, we had Mecanum wheels like this, and it was it wasn't collecting the balls as nicely as we wanted it to. It would mostly kick them away instead of funneling them towards the center. And we were using those at our Grand Forks competition, and it was not very good. But when we got back from competition, we were talking about what we saw and what we liked from other teams' robots. And we really liked people's like 2-inch 3D printed Mecanum wheels, because everyone seemed to be using those and they were great. But 2-inch was such a major change for our intake that it just wasn't going to work. So we designed our own 3-inch 3D printable Mecanum wheels, and they worked beautifully. We have a couple videos of them. They're perfect, pretty much. The climb, I didn't design this, but Ben, our team lead, did. It was originally PVC pipes. I'll see if I can find a photo. Maybe it's in here. Yeah, you can kind of see it here. There's PVC piping, but since they were circular, when you lift the arm up in the air, the hook would sway in all the directions and you could never get it to line up nicely. So we are redesigning it to be aluminum box tubes so that it can't rotate, because a square in a square, it can't spin, you know, cool stuff like that. And we also, seeing other people's robots, we really liked the constant force springs that people were using on their climbers. So we're adapting those to work with our new system. So it's not motorized to go up in the air, it's only motorized to pull the arm back down. Yeah, and then I'm just gonna play some videos and then answer questions probably. So we have, here's a clip from Mira Field where we do most of our practice. This is some autonomous testing. Hopefully this is the one that works. So as you can see there, hopefully, we're choosing to start from the really far side of the field. Here's a drawing that I made a second ago. Most people's robots were starting like around here or here and shooting up into the goal. But we chose to try and stay as far out of the way as possible. So we had an autonomous program starting way over here, and it would finish right about here, so that we were out of the way of the other robots. And we did low goal. We can't shoot the high goal. So the idea was to be as unintrusive as possible with our autonomous. Here's a clip of the old Mecanum wheel intake. Hopefully it doesn't work. Yeah, see, it doesn't work. And then good Machinum wheel intake. This is a good one. And we threw this together right after we got back from competition, a little bit before we got kicked out of school. So we're just using plywood for the arms, and that's how it is right now, the robot in its current state. Here's a beauty shot of it in front of the school. Yeah, I don't think I have anything else to say.
Perfect, thank you. There's one question in the chat, like how did you, are those custom climber guides shown in your CAD?
Like this piece here, or?
Yes, those pieces that you highlighted.
Yeah,
there.
this one here. Yeah, we were planning on 3D printing these pieces and putting bearings there so that they can't like bend over too far. But we haven't finished the CAD model quite yet. And then these pipes here would be for the constant force springs.
And another question was, how did you automatically space the power cells in your indexer?
We originally were using timing. Oh, Nate, you want to go?
Yeah, I can speak about that. They were infrared little break beam sensors that we put within our intake. And then we also had encoders on the belts. And between on those, whenever the ball came and broke the sensor, we could move the belts we found like about 6 or 7 inches enough to create a little gap between all the balls as they came in. Does that answer the question? Oh, you can kind of see them in the
cool.
video.
Thank you.
They're slightly to the left side of the first wheel inside. There's 2 of them. Yeah, against.
I'm trying to circle my cursor around it. Any other questions, or?
I think we're good there.
Okay.
Thank you. Appreciate it. All right, we got two more. We got 2 more. I think we're going to go with chaotic, 4539. Paige? Maybe, maybe not. All right, let's move to Ryan Luchny. Ryan?
Hello. Can you see me?
Yeah.
Or can you hear me?
Yep.
Awesome. Okay. So my name is Ryan Luchny. I'm from the Gators, 5172. And I'll talk a little bit about our robot this season. How do you share screens on this?
Should be something at the bottom of your screen that says share screen. Do you see that?
Oh, there it is. Yeah. Okay. Okay, so I'll just run through some pictures first. Our general idea this year is we decided to go low. We actually thought it wouldn't really be viable to be as competitive if you were high. It turned out we were kind of wrong about that because a lot of high robots were very competitive. But we knew that Winning Alliance would have high robots and low robots, so we knew that we could go low. But that also posed some major challenges as far as packaging. So everything that we made had to be able to fit under that 28-inch mark, and so that was probably the biggest challenge for us, was making everything fit down low. So first thing I'll show you, let's see. Are you guys able to see my screen right now?
Yes, I believe so.
Can you see this gearbox?
Oh, no, I don't see the gearbox. So we just see the Windows Explorer.
Oh.
When you press share screen, you have to select screen instead of a specific application, and then it will show.
Okay. Oh, okay, sweet. Awesome. All right. Now can you see the gearbox?
Yep.
Okay, so we went with custom gearboxes. They were designed in SolidWorks and laser cut by Central Boiler out of 1/4-inch aluminum, and then we just clean them up. We actually sandblasted them to keep them clean, and I'll show a picture. This is what they look like without anything on them. Here we have our climber, this is actually our whole climber. We could actually remove it. It's kind of like a non-parallel 4-bar. And so as you can see, the cross beams are not parallel. And so that allowed us to pack the climber down as low as possible. But when it's fully extended, it had its maximum reach. And so we were able to reach the high bar in pretty much any position. If it was raised up, we could still reach the high bar quite easily. And because of that non-parallel 4-bar. Here we just have our, kind of like our skeleton frame, I guess you would say. This is the kind of the frame of the robot without any of the 2x1 framing. And we had actually completed everything and then did a little bit of redesign and remade everything and painted it. And that basically required an entire robot teardown. And so as we were rebuilding it, we put all this stuff together, and it was like under 3 pounds or something, that whole frame set up there. It was extremely light because of all the holes in it, and it was all aluminum as well. So here you can see we're starting to put the frame into the actual drivetrain. And so at first we started with a center. It was actually a custom wheel with blue nitrile tread. This custom wheel, we bought the extrusion from the 6-inch wheel off of Andy Mark. And so we just cut a chunk of that off, and we turned on the inside to make it really light. And basically it was a lot of lathe work. And then we put this blue nitrile tread, and it's 1.5-inch wide tread. We did that to get the maximum traction possible. But it turned out that driving over the barriers was not too kind with this type of wheel setup. We didn't have any steel barriers to test with in our practice time, so we weren't sure how this would actually hold up against steel barriers on the field. But we ran this at the Great Northern Regional, and it worked pretty well. But by the end of it, these middle aluminum wheels had actually been dented in, and they had dents on the corners of them. And so immediately after we got back, we actually switched to pneumatic wheels, hoping that we would be able to use them at the next regional. But of course, that ended up not working out. But we did test the pneumatic wheels, and they work great. So next, we're starting the pneumatic plumbing and the wiring. That's our solenoid setup down there. We have a solenoid stack. As you can see, these bumper frames, these frames that go above the wheels here, this is chromoly steel tubing. And we really, really love our steel tubing. We use chromoly. As you can see in the back there, like right here, it's all chromoly steel tubing. We use that stuff all the time, pretty much everywhere on the robot, and it's super light and strong. So here's another picture, kind of a bad picture. Here we get pretty much most of it assembled, and this is our 4-bar climber. It's actually extended up right now and held by zip ties. And as you can see in between the linkages, there's a spring right here. I'll zoom in on. There's a spring right here. And so what this allowed it to do is when it was all the way down, it was actually compressing that spring. So when we released it, that pressure actually lifted it, or helped the pneumatics for the climber lift it up. In this picture, we don't have the pneumatics on yet, but I'll get to a picture that has that. Okay, here we are weighing it for like one of the first times. No, not for one of the first times. We were actually underweight for a lot of the season. We were like 10 pounds under for like the first time we weighed, and we were almost done. And so we were very surprised with how how light it was. Of course, by the end of it, we did finally get up to the maximum weight limit. Here we have a picture that kind of shows more of the design. So these here cylinders, one on each side, that's for extending our climber. And that, those are, I believe, 18-inch extension. No, maybe 12-inch, I can't remember. But they were plenty of power. I would show you a video if I could find it, but it was extending in less than a second. So we weren't too concerned about the power of the cylinders. In this picture, I'll just unpack a little bit more of the stuff here. The intake flips out with this cylinder right here. And above it, there's a little black tube. You can't really, it's kind of hard to see, but this little black tube, inside of there is a spring. And this rope here is attached to a pulley up here, it's kind of hidden, and down onto the intake. And so basically when the intake flips out, it wouldn't slam so hard. And when it was lifted up, it would actually help it extend out. And so that's kind of a little nifty trick that we had for the intake. It's kind of hard to see. Here we can also see our shooter a little bit. And so our turret was like, let's see, 270 degree about, or maybe it was like 280. No, I don't know. But anyways, it had a limelight on it, and it was 2 Falcons, and it was 18 or 24 tooth to 18 tooth. So it was geared up slightly. That allowed us to reach speeds of about 7,500 RPM. Of course, in competition, we never ran that high. We only ran up to like 6,500. That's all we really needed. We also have a fully adjustable hood, and this is ran by a servo with a gear and this rack. It's just a rack and pinion setup, and the pinion is actually laser cut out of aluminum. And so that setup is actually quite reliable. I was surprised how reliable it was, not being supported by the axle of the shooter, but that worked quite well. Here we can also see our control panel mechanism, and this is just a set of chromoly tubes that are telescoping with a cylinder that pushes it up. And we decided to go and attack the control panel from the top side, and we actually would stick with that decision. I know a lot of teams, actually I didn't see another team that went from the top. I didn't see anyone else, but we actually really liked that because it gave us quite a bit of forgiveness as far as where we can line up, and it seemed like it worked pretty well. So then it also was driven by a Neo, and this whole setup here with driving the control panel mechanism was like we could actually reverse it 180 degrees and do it from the front side if we wanted to do that. And on the side, we also have the color sensor sticking out, which we had to disable after we were at competition. It turns out that the Rover Rio has some issues with the I2C port, which is what the color sensor plugs into. And it would actually cause crashes in the robot. This was happening at California with the Citrus circuits and with Hawaiian Kids and everyone. So it seems like everyone kind of disabled their color sensors from Rev Robotics, or at least everyone that was having issues with it. But we just ran it manually from then, and it still worked. Okay, it looks like that would be the end of that. But I can, okay, no, here we go. Here it is with the bumpers. Here's another picture with the bumpers. And all this climber is also chromoly steel tubing. And our intake framing, which you'll see right here, this is all chromoly tubing, chromoly steel. And we really like to use that because it's just so easy to work with and so easy to weld, and it's also light and strong. There's actually several occasions where we slammed into the wall with this, and it did not hurt it at all, like nothing bent. There was once where we hit someone else and we got a penalty for hitting them. That was an accident. We did bend this front tube, but we had spares with as well, so we could flip that or switch that out. Here's just another picture. So this is kind of like a comparison for the shooter anyways, unpainted versus painted. And so the color scheme that we went with this year is slightly different than what we usually do. Typically it's more like black and blue, but this year we went with more of a highlight of white. And so this whole climber frame is actually all white, and that was kind of a controversial decision on the team. But we had most of it CAD'd in SolidWorks, and so we could actually check out the colors before we sent it off to get painted. And so that was kind of different. We never used to have that much CAD'd to where we can see it painted. So yeah. So now I'll show you some quick little clips of everything working. I don't know if this is laggy to you guys, but this is the control panel mechanism working with the color sensor. We did get the position control working as well. Or color position, I guess. I don't know what to call it. Here you can see a little clip of our fully adjustable hood with the turret moving as well. And so we found it very advantageous to be able to shoot from pretty much anywhere we wanted to on the field. We basically had a lookup table that had all the different different pairs of distance reading from the limelight, which the limelight gave a distance reading, or we could calculate a distance reading from the limelight, shooter RPM, and hood angle. And so we created these points in a big table and had like 10 points in them, and it would actually be an interpolating table. And so when we go to shoot, it interpolates based on that distance reading from the target. And so it would interpolate between the RPMs and between the hood angle. And so it was basically fully automated. No matter where we were on the field, it would automatically adjust to RPM and hood angle. Here we can see the vision tracking with the limelight. We were very, very pleased with the limelight. We maybe could have got faster results, but I don't think, in our case with this turret, the system is not limited by the limelight's capabilities, but it's limited by the speed of our turret. And so it couldn't quite keep up to the rotational speed of the robot. But it did a great job, as you can see. We could pull up and it would line up pretty quick anywhere. So here you can see one of our super, super safe shooter prototypes. This is just a slow-mo video, but it's really safe, I can assure you that. It was very powerful. We were playing around with doing a double-sided wheel shooter like this, but we finally decided that it wasn't going to be accurate or consistent enough because, but I mean, and also packaging, it was not quite as easy to package as the flywheel shooter that we went with. So that's why we went with this. And then we found that this one was actually a lot more consistent anyways, and we could get quite a bit of power from this. We could actually shoot from behind the control panel. We never did in competition. We didn't find a need for it, as it seems like it made our shots needlessly inaccurate. We could just as easily drive up closer and shoot from anywhere in front of the control panel and maybe lose like a quarter of a second. It doesn't save much time because when you shoot from far away, you have to actually take longer to line up and you have to shoot slower to allow everything to be up to spec more. And so, yeah, as far as programming goes, this is probably our most complex robot as far as code goes. Our autonomouses, you could see that we did have motion profiling, and this is a system that's based off of the Cheesy Poofs 2018 motion profiling system, and it worked very, very reliably. We have an encoder on each side of our drivetrain and on the front axle, sorry. And from that, we can get our distance readings, velocity readings, acceleration, and do the motion profiling from that. We also could shoot while moving with the limelight, but we weren't doing anything in the code to compensate for the linear and angular velocity of the robot to make it accurate. We could have easily done that. We were actually planning on doing that for Worlds if we would have made it, or for the next regional. I think if this regional would have still been going on, we probably would have had that by then, and hopefully had a 10-ball auto. So yeah, that's kind of the overview, or that's the gist of our robot. The shooting is automated quite a bit. Basically, you enable a shooting mode, and we have several different shooting modes. There's a rapid fire, or what we call Spitfire, because that's the name of our robot, is Spitfire. We have a Spitfire shooting mode, which just basically it rams them through as fast as it can go, and it's usually not quite as accurate, but it gets them up there. And then we have a regular shooting mode, and then we have like a calibration shooting mode, and that'll calibrate our shooter for like the shooting lookup table. And so as the competition goes on, the balls get worse and worse, and so the balls shoot differently. And so we had to figure out some way that we can make it keep shooting, and so keep shooting accurately, I mean. And so we had a calibration mode that we could just go to the practice field, like after a match or something, if it was shooting off, and we could adjust it there. Also, this intake, as you can see, we didn't go with any mechanism design. As far as I know, there weren't too many teams that went with this type of design, and we're pretty happy with it. One thing that does kind of stink about it is that it does draw a lot of power. So we actually have one Neo on each side of it. So that's two Neos driving it. But we found that it worked really effectively, and it could center the balls really well and suck them in pretty fast. Maybe not as fast as like an over the bumper intake, but we found that this year mechanisms, like in our testing, the mechanisms just weren't going to work out, at least the way that we were trying them. It seemed like it would actually rather suck the ball or squish the ball into the bumper than center it sideways. And so, I mean, we did try mechanisms, but we figured that this would just be more effective anyways. And so we just went with this. And so as our build season went on, we started with mechanism for like one day, and then we were like, okay, I don't think this is going to work. And so we switched to trying this design, and we had pretty much a final product on this intake done after the first week. We also had our gearboxes, our drive gearboxes done by the first week, and we had started prototyping our hopper system and our shooter system. And so through week 2, 3, and 4, it took like 3 solid weeks to finally get this hopper system down, which was very, 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 very time consuming. It seemed like every little change you made to the hopper introduced 10 different new problems that you had not had before with the old hopper. And so I think that could be attributed to these balls have really sticky texture on them, and they will grab onto each other like nothing. So as we suck them in, we actually have a vertical hopper, like a single file hopper, and the balls just kind of pop up there vertically, and we have enough space for 5 balls in there easily. It just depends on how the balls stack up in there. In fact, at competition once, I think we sucked up 7 balls, and it actually still shot the 7 balls without jamming, which was kind of a surprise to all of us on the team. But yeah, this front roller plate, it's being blocked by the intake. I don't know if I could find a picture where it's not being blocked, but we have a roller plate on the front, and that's where the balls would rest against when they're in there. And that roller plate is actually made of artificial insemination tubes for cows. They're polycarbonate rollers, and they work just great. So we just use filler rod going across a Lexan plate. I'll pull that picture up again so you can at least see some of it. Oh wait, this is a video. Okay, so you can see a little bit there. You can see like 3 rollers of it, but we had to figure out some way to make some kind of small compact roller that would allow the balls to roll on it very smoothly. And so, yeah, they're polycarbonate rollers, and then we just had them rolling on welder filler rod. And so that provided for a very frictionless surface for the balls so that they wouldn't jam as easily. And now the final thing I would like to talk about is our weight shifting climber, or side shifting climber. And so this year we found that we figured in build season that a lot of teams would be able to climb just anywhere on the bar. We thought that anyways, and I think that that is true for the most part. A lot of teams did have a climber, but a lot of teams' climbers broke or didn't work, at least at the first competition. And so we were trying to figure out some way we could almost guarantee that ranking point for climbing. But the thing is that one way or another, you have to rely on your teammates at least somewhat. And so if you had a buddy climb where you could lift up another robot, which we figured that we could actually potentially do on our robot, but we never went through with it. You would still be relying on your teammate to drive onto your climber bars, which would, you know, if you can't trust them to climb on a bar that's sitting still, I don't know if I would trust them with having like a thing hanging down below our robot. They could potentially just smash through it and break our robot. So we went with a weight shifting climber that would allow us to hook up anywhere and adjust our position on the bar to level it. And we found it quite advantageous, especially if our teammates like were planning to climb in a match, but they actually didn't, or they broke down in the middle of the match and they told us that we'll have to climb alone. Then we can hook up on the side and we can side shift all the way to the middle. And so that was nice for that. Just giving us the versatility really helped out a lot. And now I'll show you a clip. So this is just a 30-second clip of our performance at the Great Northern. It shows us shooting a volley of 5 balls, backing up and doing the control panel, and then line up for a climb. So our climber was, we actually really liked our climber this year. Previous years we had like consistent climbers, but they were somewhat slow. But this year we really decided to go all out with the climber and make it as fast as we could and also consistent. And so, yeah, our climber, after hookup, our climber takes like maybe a second to lift up from the bottom to the top. And line up a lot of times only took 3 seconds or less. It was quite an easy system to line up with the way we had it. We didn't have any springs or anything like that. It was just 2 falcons. I was actually going to show you that. 2 falcons. Here we go. The climber gearbox. This is all it is. It's 2 falcons on the inside, which we actually later switched it to the outside. 8-tooth pinions on a 72-tooth gear, so 9-to-1 reduction. And the winch rope is literally just straight on this hex shaft. That's all it is. It's a very, very compact, very little reduction. There's no brake or no ratchet or anything like that. It just uses the brake mode of the Falcon 500s, which seemed to be plenty to hold us for more than 5 seconds. And so that's all the reduction it really was. And so we were happy with that system. I believe that's all I have to show you. If anyone has any questions or anything.
Thank you, Ryan. I think because of time, I'm going to ask you to answer questions in the chat.
Okay.
And do it that way because we do have one more presentation, so I want to get to that. So
okay.
Thank you very much. Chaotic, are you there? Can you? So they figured it out maybe. Let's see. Maybe not. We might have. Well, let me give you answers to the last trivia question, and then we'll give you one more trivia question. And if we can't get Chaotic on, Ryan will spend a few minutes maybe answering some of the questions that are in the chat. But
okay.
Let's see. The answer to their last trivia question was 40 students on the video, and it was Avdol and Zachary who answered that correctly. Zachary conveniently waited about 3.5 minutes to answer the question, which means that he actually watched the video and counted the students. Very smart. So here's the last trivia question. How many Minnesota FRTC teams have competed at the Detroit Championships in 2019? Okay. And Paige and Chaotic, I'm hoping you're online. If not, oh, I'm sorry we're not going to be able to get you. Let's see. Okay. Ryan, let's answer one question here, and then we're going to have to move on, I think. So
Okay.
You can take your pick. There was a question about jamming. Question
Okay,
about,
let's see. Oh, how much weight? Okay, how much weight do we save by drilling out the Coulson drive? I don't know specifically. It's not too much, but any little bit helps. We just figured that we do it anyways because we have the tools to do it. We just use a rotary indexing head on the mill. Our source for chromoly is from Walbros. Yeah, okay. Mary answered that. Okay, our thought process in making the intake we did. I sort of explained that in that the mechanism wheels, we didn't really work out. We didn't think that they would actually work, so we just went with the centering system of using bands. It was very similar to 973 in 2012, and also Madtown 1323 in 2012. They went with the same type of system. How were we able to complete our initial build so quickly? Well, I wouldn't say we did it that quickly. I guess, I don't know, a lot of our prototyping came from Central Boiler laser cutting parts for us. And so also this year we were much more heavily involved with CADing everything, as opposed to the past. We just kind of like rigged everything together by hand. But the computer aided design helped us a lot with prototyping speed, and I don't know, I guess we just had a strong build team that allowed us to make things very quickly. Issues with jamming. Yes, we did have some issues with jamming. It was a lot worse during earlier in build, but we made changes here and there throughout to make it so like some matches it wouldn't ever jam at all. We actually ran through like 200 plus balls through the shooter and it never jammed once. But then sometimes, a lot of times our jamming at Great Northern actually came from accidentally intaking more than 5 balls. So if we had accidentally intake 6 balls, it would make our whole hopper system more prone to jamming. And so that was one reason that our thing jammed. And yes, our intake will flip up and down to prevent the jamming, or we can do that. And also we had an autonomous function that would flip the intake in and out to also unjam it. So yeah, our autonomous would actually detect like how fast we're shooting the balls. And if we go for so long without shooting a ball, it would flip the intake to potentially unjam. And it actually did do that, and it actually did unjam the balls sometimes that way.
Ryan, I think we've got Chaotic going here, so let's move on to them. Chaotic, are you online?
Okay, we'll try this again. Can you hear
Okay,
me?
there you go. Good to see you.
Awesome. Awesome.
Okay, I'll get this shared.
So just a couple, we don't have a whole lot, just a couple pictures of our robot. What we decided to do, we decided to go tall right away. We thought if we went small, we knew 5172, 3750. We knew those guys that we knew we would see at Great Northern. We knew they would go short. So we decided we'd go tall to try to complement them some. We decided right away to, I'm just going to circle a couple of things here. We went mechanisms for intake right away, just to these orange belts into a gravity fed hopper system. we tried doing belts, nothing but everything jamming up. So we decided as an option to not do that. We have just a picture of the robot. No?
No, I have to go this way.
Okay. Okay. So
This is the best thing.
we went, we started out with 4-inch wheels for a shooter. We have 2 Neos, just free Neos. We have a polycarbonate hood. We could drive right up to the wall, shoot into the high goal from right up against the wall. These air cylinders just push that back. We could also shoot from behind the trench, run. We put a wheel spinner on it last week before competition. We focused mainly on shooting and climbing. Our climber is just a single stage elevator run off of these 2 continuous springs. It's got just a rope going up, rope coming back down. Our brake mechanism is fairly close to a few other robots out there. We went with just a pancake cylinder to stop it from back driving. We went 6-wheel tank drive, modified West Coast, Falcon 500s for that. Just a single Neo or just a single motor for running our intake. We went staging. We can hold 3 balls down here, and then in the front of our robot, which I'm sorry I don't have a better picture of that, we actually have 2 or 3 balls that we could stage up in this area up in here. And like I said, we went 6-wheel. Oh, there we go. There's a better picture. We could actually stage balls here. We have a trigger to our shooter. So it shoots it from here up to here. And then from here, our shooter shoots it out. We had actually thought about at one point doing intake on both sides of our robot. So you could drive forward or back. One of those things you're working on and your season gets canceled. It is what it is. Other things that we did, here's a little bit better picture of our climber. All we did is took a piece of tube, cut the ends off, and bolted it right to it. Put a little bit of tire tread on there so it doesn't slip. Never had an issue with it. Hooked up, climbed up, somewhere between 3 and 5 seconds, depending on where you're at in the field. All right, we went to Great Northern. We shot a few times from behind the control panel, and like everybody else has said, with the balls getting damaged as much as they were, we went from 70% accuracy back there to about 50 pretty fast. So we decided that's probably not our best option. So we just started making the run underneath the generator switches to do our shots. Just a floor intake. We didn't do a hopper system. We couldn't drive up to it and just drop them in. Since Great Northern, we have actually completely redid our intake. I know some of you have seen it, some of you haven't. It's so much faster and so much better. We went over the bumper after the fact. I know nobody here has really talked about the outreach. A whole lot of teams have talked about the outreach that they've done this year, but I'm going to turn it over to Paige, and she's going to talk a little bit about what we have been doing.
All right. So in terms of outreach, we kind of just like to keep it separated into 3 different categories. Outreach within our school, within our community, and then the FIRST program as a whole. So the first one that we kind of like to talk about is that when chaotic robotics was started 7 years ago, there was not really a STEM program in our school, and we kind of helped get that into the curriculum by starting a robotics class and getting weekly STEM into the elementary as well. So here we have some pictures of our first robotics day. Sadly, the one that was supposed to happen this year is canceled due to the coronavirus, but we tried to show our robot to some younger students as well as, show some STEM activities. And then this last, I would say February, early February, we went down to the elementary and held a STEM day with the younger kids, showed how STEM can be used and just did some fun activities with them. 3 years ago, we also started a recycling program in our high school, which was really good. Due to the county moving the bins, we didn't have one, and we were able to start it back up, get a bin back in there for paper and plastic, and then our kids go every 2 times a week, 2 times a week to collect the recycling from the classrooms. Next, we've got our community. As many teams do, we have demos every year, parades, that kind of a thing. In 2018, we also got an Adopt a Highway, which has been very fun and for all of us to do as a team. Then we also have done our second annual food drive this year. We're hoping to raise over 500 non-perishable food items by the end of 2021, and we're about 300 right now. So I'm thinking that's pretty cool. We also started to mentor and assist other first teams. Rookie team out of Battle Lake, we were able to help them this past year, and these are pictures from Monaga, team 4703. And we were able to go to their shop, and they've come to our shop as well to kind of show them, how the first program works and how to just get along with it, if you will, and as well as help them get their first chairman's presentation done, which was very fun for us. And then 2 years ago, last year we had the New York Mills mechatronics class come to our school, and we were able to help get a team started in New York Mills. They were supposed to compete at 10,000 Lakes this weekend, but that was unfortunately suspended. So these are just some pictures from them coming to our shop. Another thing that Kaylee had mentioned earlier is the Go Green Challenge that we started. We invited about 28 other teams to recycle aluminum cans, and it was kind of in the spirit of gracious professionalism, competition to collect as many aluminum cans as you could. Yeah. Oh, the first aid kit as well. I don't have any pictures of this as well, but we actually created a first aid kit, not necessarily for safety, but outlining some of the bigger aspects of the first program, business, robot driving, design, all that kind of thing. It's about 40 pages long, and you can find it on our website, chaoticrobotics.org. And we are hoping to add a programming section this next year, as well as get an audiobook. So yeah, that's all I've got.
Awesome. Thank you so much. Other questions for Chaotic? A nice combination of robots and outreach. That was really great. Thank you. Well, we're done with our presentations. We spent a lot of time together. It's been really great. I was just going to ask anybody who's left, do you have any just general questions about first, next year, maybe, anything that we can answer for you? Chaotic, there was one question for you. Did you ever get a closed loop velocity control working on the shooter?
To answer your question, Ryan, no, we did not. As a lot of teams know, our issues are with programming. We don't have programmers. We're working on it. We're still going to work on this robot as soon as we get a chance to get back to it. In this couple of week break here that we have, we're going to get some programming help and programming smarts ourselves for who we have as mentors and team members, and we're going to hopefully get it working. So thank you.
Good, thank you. All right, Tristan has the question that I think is on everybody's mind. Has the season been canceled, or are they still calling it suspended? That is, any hope for competition still? I think I'm going to turn that question over to Mark Lawrence if he's here.
You know, I wish I had an answer for it. You know, they're still saying suspended, but as time goes by and things get pushed out more, you know, the governor's got us locked down till May 4th at this point for schools. So, you know, that doesn't leave much in the school year, you know, and then trying to put on these events over the summer has its own set of challenges. So stay tuned. We'll certainly do what we can because we all know we want to play with the robots we've got. For those that didn't have a chance to do it, they're looking forward to it. And for those that did, as you heard several times today, they've all made improvements. So if we can, we'll try and have some kind of competitions. Otherwise, we're probably looking at fall for the postseason events, and we'll see if we with the fields we've got now scattered around the states, it'll be much easier to put on these small regional competitions in those facilities. So, you know, we'll certainly be looking at that as we go through the summer.
Another question, Mark, was what would happen for the teams that qualified for the canceled championships? Do we know anything about that at this point?
Yeah, right now they're not saying that that's going to extend into next year. So that's, you know, it's truly unfortunate. So we'll see how that goes. As you know, things will change, guaranteed. You know, they're first is trying to put together what they can at the moment. You know, I think they're focused on this May 2nd event, and certainly, you know, we'll be doing some announcements of winners of chairman's and Woody Flowers and Dean list in between then. There's more to come out of New Hampshire on those issues.
Good, thank you. Are there any other questions? I think the only thing locally is that at the University of Minnesota, which is where our meetings are supposed to be this weekend, the campus is not open until at least May 13th. That's the end of the undergraduate semester. And I think the hope is that campus will be open again early June, but that's just a hope. And so, you know, we just don't know at the present time kind of where we're going to be. So I think just kind of stay tuned. I think there'll be more information coming from FIRST and from the local people that are here to try and get all these robots on the field. And that's really what we want to do is, particularly the 75 teams that have not competed yet, we really want to find a way to get them to play Infinite Recharge. So that's really what we're aiming for. Mark mentioned the first virtual showcase, so that may be our final comment, which is taking place on May 2nd, and I think it'll happen via Twitch. And FIRST is looking for teams to contribute what they call their favorite moments, stories, monumental breakthroughs, and team accomplishments of the first Rise season. And they're asking teams to use the hashtag FirstFFC, which is in the chat, as a way for you to kind of communicate and send your videos, your stories, your photos, all of those kinds of things to them. And hopefully that'll be a good event that we can all participate in. And if you don't know already, the 2021 teaser was released, and so that was a couple of weeks ago. So there's also that to kind of look forward to, and you can find that on YouTube, and you can kind of begin guessing about what next year's game might consist of. So, anything else at this point? Any other questions or things to discuss? I am really appreciative of everybody kind of participating today. It was a really great boost for me mentally to see all of you and to hear about all of the great work that you're doing. I think the robots are really amazing and so creative and ingenious and beautiful, actually. So I mean, that's the other thing. So please just stay safe and stay healthy. And during this time when we're not together, just remember to try and find ways to kind of stay connected with each other and just keep the inspiration going. So we will get this hopefully recording posted on YouTube so you guys can see it and refer back to it. And everyone stay safe, stay healthy, and thank you.
Thanks, Georgie.